Let's kick off, shall we? All right, so welcome to the second last chapter of the introduction to network. So this one's security fundamentals, and the next chapter is all around configuring the routers and switches interfaces so that we can pull all the lads together and finalize quite a number of the units that cluster together that this course covered. So Jacob's arrived, so without any further delay, I'll kick off. So we'll have a look at what security threats and vulnerabilities are and how they relate to devices, and identify some of those attacks and mitigation techniques. And we'll talk about how we can harden up the devices. When we talk about security hardening, we're basically talking about protection. So, types of threats. So, information theft, data loss or changes, theft of your identity, even disruption of services, cost, businesses lost time and money due to those attacks. Now, these attacks can be launched and take advantage of either software or hardware vulnerabilities within your equipment, and some might be via social networking, so getting to know your staff and being able to guess their username and passwords via social engineering. So we'll have a look at these in a little bit more detail for the common ones. We won't go over the whole thing. Security is a discipline all to itself, and there's many security courses out there that just discuss security aspects and how to do it. Okay, so technical vulnerabilities, which would be vulnerabilities within the protocols themselves, such as TCP/IP, or even within the operating systems themselves. Now remember, we have network protocols, network operating systems, we have client operating systems, and we have operating systems for all the devices that run the network and are connected to the network. And some of the common things that are vulnerable are accounts that aren't secured properly, misconfigured services, in other words, services that nobody's using and possibly not even monitoring, that are left on by default, and equipment could be misconfigured, so ports left open, that sort of thing. And one of the easiest things for people to guess or break is weak passwords. Okay, a lot of people use well-known words and things like that for their passwords, and they can be intercepted and impersonated fairly quickly and easily using a dictionary. So one of the things that we need to have in a company is a security policy, and one of the things that the security policy does is it tells us what needs to be secured, how it's going to be secured, and what happens if a breach occurs. who's responsible for what. So if we don't have a written security policy, we can't enforce strong passwords, we can't enforce authentication requirements because the company hasn't set up any guidelines for it. Okay, and as a network guy or girl, you are responsible for enforcing the policy of the company. You do not make up your own thing and go off on a tangent. You must enforce what the company mandates. Okay, so physical security. These are threats to the actual physical hardware, your routers, your switches, servers, workstations, anything somebody can lay their hands on is open to threats, physical threats. Okay. Environmental threats are things like equipment closets and that not being cooled, so they get too hot, or the humidity, in other words, the moisture in the air gets too high and damage the equipment via those extremes. Other things like electrical threats are spikes or lack of power. So if somebody can control the power to the building, they can depower the network, they can put taps in place without anything being monitored and then turn it back on and get all your traffic, for example. Maintenance threats, in other words, electrostatic discharges. In most situations, this doesn't occur these days in your sort of host, your workstation environment, but it certainly can occur, and we need to take steps to prevent it. So this is, having the wrist straps and grounding ourselves out against the equipment before doing any internal maintenance to it. Spare parts needing to be on hand. Damaged cabling, which could create electrical cross threats or things like that. Poor labeling. Oh, yes, that's understated. This one should be bold and underlined. The number of cabling closets I've opened over the years that have no cabling, let alone poor labeling. Every cable should have a label on it stating where it's going to. All right, to and from. Or else, how are you going to keep track of where things are and whether they're plugged in correctly? So, types of attack against your network can be from viruses, worms, Trojan horses. Now, these are all generally labeled as malware. Now, the idea is they all pretty much work similar to each other. What's the difference between viruses and worms? Well, a virus tends to need you as a human to have some form of interaction with the virus itself before it can propagate. Whereas a worm, once it's in there, is self-propagating. So it doesn't need that human interaction to propagate. So a virus, typical traditional definition of virus is the attachment to an email and you open it up and then it propagates. A worm is where you download that free piece of software and it's been modified by a third party. So it looks legit, but it's got an extra bit of code in it, and whenever that is run for the first time, it kicks off the worm and it propagates itself throughout the system, attaching itself to other files and throughout the system, and off it goes and processes. Trojan horses are like worms. They're legitimate software, but they have a hidden payload in them, and they can affect the okay, so again, they look legit, but they've got a hidden payload and they reproduce. Okay, so again, they're like a virus. They need a human interaction for it. So worms are the only ones that self-propagate. Next, we've got the types of attacks. So we've got reconnaissance, access, and denial. So reconnaissance is just like the name implies, their discovery. So they're mapping of system ports, services, trying to find vulnerabilities within the system. So access attacks are where the attacker is trying to gain access to system resources or escalating privileges on accounts. So basically manipulation in an unauthorized manner so that they can gain access to something they're not authorized to have. Denial of service is just flat out trying to rob legitimate traffic from having access to your services. Okay, now one of the things with denial of service was it was very easy to do early, because in the early days, domain name servers out on the internet were manually updated, and it took a long time to change DNS records and that through the internet. So if somebody attacked via a DNS record, it took a while. They couldn't just quickly change IP addresses, for example, attached to, Microsoft.com, for example. It now has a batch of IP addresses that they rotate through continuously just to break cycles of domain name attacks. So denial of service attacks. Okay, so tools that we can use for reconnaissance attacks are legitimate network tools. And let's look up US examples. NCAP. There's a whole heap of tools that will enable us to monitor the network, and these same tools will be used by hackers to attack the network. Okay, so basically what they want to find is valid IP addresses so that they can then use that as an attack point for whatever they're trying to attack. So once they've got a valid IP address, they can launch more reconnaissance or access attacks or whatever they wish against those assets. I'll eventually spit it out. Alright, so access attacks, as we said earlier, were trying to gain access to resources via attacking passwords, so they could be brute force where they've got a dictionary of password names and things like that, and they just cycle through, keep repeating, okay, that's a user account that asks for a password, and just cycle through one password after another, going through the dictionary, for example. Trust exploitation is where you've got a trusted system that's compromised, and because it's got a level of trust, they're exploiting that trust and trying to escalate the privileges that they can gain via that trusted system. Okay, classic example is the laptop that the parent takes home that allows the kid to play on, and they download the free games and stuff, which compromises the system, for example. Port redirection. Okay, so these are classic redirection of ports. So they use a port, valid port to come in, and then bounce back via another port to attack another host. Okay, so they can gain access to other systems using that trust and redirecting ports to gain access to things. Man in the middle is quite easy to do. This is where a device can impersonate a legitimate thing such as a gateway. Alright, remember we have an ARP protocol, address resolution protocol, that says I'm looking for the MAC address of this IP address, the gateway, for example. A device can respond to that impersonating the gateway. It says this is the MAC address for the gateway, send it to me, and then it forwards that traffic after expecting it to the legitimate gateway, and then because it is the source of the conversation via the gateway, any replies come back via that man in the middle device and back to the originator. So it can be quite a powerful type of attack. Denial of service, they've all, well, I won't say that. Over the years, there's been some pretty high profile denial of services over the years. All your major companies in IT copped them over the years. Microsoft, Google, they all got hit. As I said earlier, it was very easy to do that because they couldn't quickly change domain name entries. That's now been changed, so we can now do dynamic and rapid updates of DNS master tables throughout the internet relatively quickly, based on the old system anyway. The way that these attacks occur is basically just flooding a legitimate service with requests that are could be SYN attacks, they could be all sorts of different things, and basically what they do is they tie up the buffers and other resources, memory and things like that within the entry points so that legitimate traffic cannot be processed. And how they do that is by sending lots of information and to that one point, and when they use multiple machines to do it, that's called a distributed denial of service attack. And basically we call those compromised devices that are part of the distributed denial of service zombies. So they're compromised machines that have been taken over by the hacker and are being used to disguise and amplify their attacks against the target. Mitigations. So the best defense is defense in depth. In other words, we're not just relying on our firewall, we've got other devices and procedures within the entire infrastructure to protect us. So some of the things that we use in this layered approach of security is VPNs, ASA firewalls. Now, an ASA firewall is an adaptive service appliance, which means they can do more than just a standard firewall. They can terminate VPNs. They can do all sorts of different things with it in the firewall structure. They can be intrusion detection and prevention devices. So IPSs can be built into an ASA, for example. And what this is it monitors traffic and looks for patterns within the traffic. And if it's a detection system, it just sends an alarm. If it's a protection system, okay, so IPS rather than an IDS, it takes action when it detects a pattern in the traffic. So rather than sending up just an alarm, it will actually take an action and then log the alarm. Next, you have authentication services within your devices. So within that, the ESA, WSA, and AAA services are all working together to provide authentication of services throughout the network. Okay, so whether that is authenticating a user or a device or a protocol, they all work together to secure the network. One of the other things you should regularly do is keep backups. I know we've covered that in IT Essentials as well, and we just need to protect our data. So if somebody does hack the system and delete stuff, we can restore it without too much disruption to the business. Patches need to be applied on a regular basis. Now, Microsoft is the second Tuesday of each month, unless they changed it recently. Basically, by keeping your system up to date with the latest security patches and application patches, you reduce your vulnerability windows with your keeping them up to date. Now, word to the wise, always maintain a log of how you've set your updates and how often you do those updates and patches, because having those logs proving that you're patching and updating software and systems on a regular basis is your get out of jail free card, especially if you are the security officer of the network. Okay? When you are a security person, you are legally, financially liable for the losses incurred by the company. So the way you protect yourself is by keeping very good records of all your updates and all the steps you take to protect the system. Okay, so if you can prove you've done everything humanly and professionally possible to protect the network, you get off the hook. But if a lawyer can prove that you were incompetent, you cough up the money. Just a word of the wise. Okay, authentication, authorization, and accounting, AAA. This is basically a way of keeping track of authentication. Is who are you? Prove to me that you are you. Authorization is you can have access to the resources, or in this example they're showing here, a credit card. You can have access to a certain amount of money And accounting is keeping track of what you did when you were accessing that. So again, within the credit card system here, keeping track of what you purchased using the credit card, for example. So in network terms, authentication is proving who you are. That's your username and password type credentials. Then authorization is, can you have access to this resource on the network or the file or whatever it is you're trying to access. And then accounting is keeping logs of who accessed what, when, how, and why. Okay, firewalls. We have firewalls that protect in both inbound and outbound directions within the network. Now, these systems need to be in place because you don't want all traffic going outside. Okay, you want to restrict some systems from having external access. There's all sorts of reasons why you don't want to permit all traffic going out to the internet. Next one down there is the inbound rules. So from the internet coming into your network, you want to basically stop all of that unless it's in a reply to your requests. So there's ways of differentiating whether that it's a response to traffic or not, and the different types of traffic that can reply is also tracked as well. But anything originating from the outside of your network is got to be closely scrutinized as to whether it can come in or not. Now, if you have a set of web servers and things like that that you want people to have access to, it is common practice to set up what's called a demilitarized zone where your servers that can be accessed from the outside can reside. And basically what happens is when outside traffic comes in, if it's bound for those servers, it gets redirected into that DMZ. But traffic from the DMZ cannot go inside. Okay, so it's basically stopping traffic bouncing through the DMZ and into your internal network. But your inside machines can access the DMZ to maintain the devices, access that information, and retrieve orders, that sort of stuff. So, types of firewalls. Okay, so we've got packet filtering, which is basically very basic in today's world, where we just permit or deny traffic based on their IP addresses or their MAC addresses. Application filtering, this is the port numbers, so we're looking at allowing or preventing specific applications from traveling through that interface. Next one, we're looking at specific websites, so this is known as whitelisting, blacklisting websites. You might have heard those terms before. So whitelists are websites that are permitted, blacklists are ones that are banned. And then in the powerful one, the stateful packet inspection type of firewall that actually delves into the data, not just the headers, and inspects the payload as well as the headers to find out what is actually within those traffic packets, and then recognize and filter out specific types of attacks, such as denial of service and things like that. So they not only look at all of the above, but they also look at patterns within the traffic. Okay, so that they're very much a powerful weapon in the attack or defense of your network, if you like, attack against the hackers. Endpoint security, this is securing all your devices that connect to your network, such as your laptops, servers, desktops, tablets, so on and so forth. Anything that connects to the network. So again, all the things that were said before apply to end devices as well as intermediate devices. And we need to have well-documented policies and procedures in place for this, because if you do something that is not documented by a policy, you can come unstuck, because a manager will come down on you like a ton of salt if you're just doing something because you think you should, and it may end up costing him time, because it's up to the management of the firm to determine the risk factor that the company is willing to take. Okay, so to have a totally secure network pretty much means your users can't do diddly squat, and you've got a very slow and unresponsive network. You need to balance that against an open network where users and applications can do whatever they want, but there's no security. So this balancing act between a secure network and an operational network needs to be balanced out, and that balancing act is known as the risk factor, and that needs to be defined by management. So they need to balance the operational characteristics of the network compared to the risk or the exposure to financial damages that the company is willing to take. Okay, so you need to comply with those policies. So one of the things that you can do is make sure your staff is well trained on acceptable use, the policies and procedures, so what to do if they detect something funky going on, who to report it to, steps they can take to secure their passwords, how often they should change passwords. All this sort of thing need to be taught to staff members and reinforced on a regular basis. Now, one of the things that quite often occurs is you get phishing emails, so emails that are designed for people to look at and think, oh, that's legit, and interact with, and they actually report themselves to the IT department, and you get a report of how many people were willing to help an attack and how much extra training and education you need within your personnel, for example. Device security, Cisco has a feature called Auto Secure. Now this is a automated script that runs basically that goes through and locks down your devices, and they go through a whole series of steps such as changing default usernames and passwords, implementing password minimum lengths, turning off unnecessary services and applications, and it's quite a powerful tool. But if you run Auto Secure and don't pay close attention to the questions it's asking, you can be locked out of the device. Just saying. Yes, I've seen that occur in the classroom. Thankfully, I haven't seen it in an enterprise yet, so there's always the chance. Passwords should be at least 8 characters in length, preferably longer. Should be a mix of upper and lowercase letters, numbers, symbols, and spaces for making them complex. The more complex the password, the harder it is to breach. Passwords should not be based on repetition, such as dictionary words and things like that. Shouldn't be taken after number sequences and things that can be easily guessed. So children's names, pet names, birth dates, stuff like that should not be part of your password, because these things people talk about. Okay, what's the common thing on phones today? Could you please provide your date of birth for authentication that you are who we're saying we're calling? Okay, this is your name, this is your date of birth. So all this automatic reaction when somebody calls you, I'm so and so from this, I need to confirm you're the person I'm supposed to talk to. Well, guess what? You're just handing out that information to them that they can use as information to attack the system in the network, for example. It's very easy for people to social engineer other people. People are social animals, they like to chat. Okay, so it's very easy to come along and do that sort of attack and gather those common pet names, dates of birth, all that sort of stuff. It's very easy for them to gather that. The next one is deliberately misspelled passwords. Okay, so substituting a 0 for an O, 5 for an S, that sort of stuff. Just be careful if you're deliberately misspelling words, because those common things over the years, because we've been doing them as IT professions since like late 70s, early 80s. They're well known and are now included in those dictionary attacks as well. So passwords should be changed on a regular basis, and the changed password should not be one that's been used before. So you can't just swap between 2 passwords, for example. Do not write down passwords if you can. Okay, one of the things I remember as clear as day is one of our personal assistants, they're called now. In my day, they were called secretaries for one of the directors. On their little drawer, they had a pull-out drawer where they used to put pads and things down on. They had taped to that the director's details, so they could log into as the director to do stuff when he rang up from the road and log in and make changes and things like that. So please do not write down your username and password and leave them around the workplace. They will be found very quickly and used to breach the system. It's always better to use a passphrase, which is basically series of words, taking the first or last letter of the phrases, and using that as things. So mnemonic is another way of recording it. So one of the things that I remembered was, please do not throw server parts away. And you're going, what does that spell? Please do not. Physical data network server parts. So you work out what it is. How many words were there? Please do not throw server parts away. 7 words. What has 7 layers, I wonder? Okay, so that's the sort of stuff that... So what can we do with this on the devices? Okay, so we've talked about and gone through, I think it was around chapter 5 or somewhere around there, where we did basic device configuration. So we went in, put passwords in. So we put password Cisco, then we had, login. Alright, now what we can do is secure those and say, alright, so service password encryption is a global config command, and what this does is it changes all these plain text passwords into a level 7 encrypted password. So this is a very, very weak encryption, and it basically protects your password from being seen by somebody looking over your shoulder. Next is the security password minimum length, 8. So this means your password must be a minimum of 8 characters in length before it would be accepted. Login block for 120, temps 3 within 60. So what this means is I'm going to block for 120 seconds after 3 attempts of a login within 60 seconds of. Okay, so basically on 3 failed attempts at login within a minute, I'm going to log you out, so you can't attempt to log in again for 2 minutes. This is to protect you against those brute force attacks. Alright. Next, exact timeout 5 for 30. So this is basically an idle timeout. So this will log you out of the system once the time has expired. Transport input, SSH, is when you're connecting remotely, you must use the SSH protocol, not Telnet. Okay? So SSH is the encrypted communications. Telnet is in plain text. Okay, so what you need to have to enable SSH on your system is a unique host name. It can't be router, can't be switch. Those are generic names sent out from the factory. You need to have a IP domain name configured on the device, and you do this with the IP-domain and name command. Then you run a key generator with the command crypto key generate RSA general keys modus and the number of bits you're using. Okay, so this generates encryption keys that are used to encrypt and decrypt the information. Minimum length recommended is 1024. You then verify and create a local database, which is a set of usernames and passwords under the global configuration command using the username command. You then tell it to log in using the local database rather than just login. And you then secure those virtual terminal sessions using SSH, which you can transport, import SSH. There are labs that you are supposed to do in this chapter that go through all of these. All right. Disable unused services. For example, on most routers, they actually have, especially on the older ones, they had HTTP running by default. You can come in and turn them off. One of the things you can verify what ports are running is show IP ports all. That'll tell you what all the ports are that are running. On the older systems, which are the older original iOS systems, you use show control plane host open ports to give you the same information. So in summary, we had a look at what threats were, being theft of data, information, manipulation, identity, and denial of service. And we had a look at the physical threats, whether they were hardware, environmental, electrical, and maintenance. Then we had a look at the three main types of malware, being viruses, worms, and trojans, and the differences between them. And then we had a look at the major types of attacks, being reconnaissance, access, and denial. Then we went through the mitigation of those threats using defense in depth, types of equipment that we can use to do that. And then we had a look at how we could use the software at our disposal to help mitigate the attacks by keeping them up to date, and to turn on features within those operating systems to mitigate unauthorized access. And then we had a look at protecting endpoints. So as we've talked about many times in other chapters and courses units, we need to keep our end devices up to date, secure, have antivirus software, and firewall options on the networks as well as inside the network. And lastly, we looked at how to secure Cisco devices using auto-secure and manually secure passwords and remote login via SSH, and how to check what services are in use in new and old operating systems on a Cisco device. And if you're still awake after all of that, congratulations. I'm losing my touch. Alright, so that is the second last chapter. So again, we've started adding some command structures in. So I strongly advise you to go into the material and do the labs, because you will be expected to apply some of this in the practical exam.